Yes, 0. I think you said 0. And when we plug in 2, and again, you should say, no, you're not allowed to plug in 2. Bear with me and please plug in 2. India?
I'm sorry. -1.
So by the order of operations, I have to square 2 first.
-3.
Okay, I agree with -3. Perfect. We're done with the middle. Let's plug in 4. What do we get inside the bracket?
3.
Very good. And let's plug in 11. And what do we get?
4.
Perfect. Okay, great job. So now we're ready to graph. Good, so can anyone give us the first ordered pair from left to right?
It would be -2 and 2.
Excellent. Next ordered pair.
-1, 2.
Very good. Next ordered pair.
0, 2.
Full point or open point?
Open.
There is a bracket.
Colored.
There is a
So
bracket.
that would be full.
Exactly. So we finished graphing that piece. It's gone, done. We don't look back. So now we're here.
All right, I have a question.
Yes?
So I don't understand what just happened there. Those 3 dots, they're both...
-2 for x, 2 for y. -2 for x, 2 for y.
Okay, I understand that.
-1 comma 2, -1 comma 2, and 0 comma 2.
Yeah, they're on the x-axis, and then you place 2. Yeah.
Is that okay?
Yeah.
Good.
That's right.
So this was a full point. What about 0 comma 1? What kind of point will it be?
Open.
Perfect. So 0 comma 1 is an open point. The next in line, what do I plot?
1 is 0.
Good. The next in line, what do I plot?
It's going to be 2 and 3, or
What?
2 and -3.
What type of point?
It's going to be an open point.
Very good. This is a quadratic function. It opens up. It opens downward. It has a maximum because the leading coefficient is negative. Okay, then there is a gap. Next ordered pair, please.
It's going to be a hard point at 4 and 3.
1, 2, 3, 4, and 3. Full point, very good. And then 11, 4. I know you trust me. That's it. Notice I specifically used 3 different colors to make sure you understand that, first of all, there is a gap here. There is nothing because the function is not defined between 2 and 4. It's not defined at 2, but it's defined everywhere between -infinity and 2 without 2, up 4 to infinity. Exactly what we wrote there. Can anyone now establish for us the range? So this is our function f of x. The whole thing is the function, not just this or this or this. All these 3 pieces make up the function. So can anyone give us the range of this function now?
-3 to infinity.
Very carefully. Okay, so let's do this together. This is not a trivial situation. Nothing, nothing, nothing. No. -3, no. Yes, 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 yes. 1, no. 1 is not. So for now, I have -3 to 1. Then a gap right here. There is a gap. But then it jumps just to 2. To write 2, I cannot write this. That's not the way we write 2. We write union embraces 2, a finite number of numbers, we use the symbol for the set notation. And now union, again, there is a gap. There is a gap here. And the gap is between 2 and 3. So union 3 to infinity. Again, this is not a trivial situation. Okay, this was a piecewise defined function. I'd like to quickly look at the finding the equation of a line. This is very important for the entire course, problem 6. And then I would like to talk about the difference quotient, which I need in the entire chapter 2 and moving forward. So it's not a waste of time to review that. Any questions on the piecewise defined function?
I have like a slightly unrelated question, just with the whole graph not touching. How is the piecewise function compared against the arctan function, since it never touches in the middle? Is the
Arctangent,
function
first of
piecewise?
all, arctangent, first of all, is a function defined everywhere. Arctangent is not a piecewise defined function.
Oh, I'm sorry. The one above it. Yeah. No, that inverted one. Okay, I see.
So arctangent, first of all, it's not a piecewise defined function, and it's defined on all real numbers. This one is,
Yeah, that one.
could be a part of it, of a piecewise defined function. I can have, instead of 2 here, I can have 1 over x minus 1. So then this part will be part of the 1 over x minus 1 graph. So I can have any combination here, any types of functions. So this one is not a piecewise defined function. Okay, this function, oops, where is my previous page? So this is not a piecewise defined function. Okay, it doesn't have 2 functions representing this. It's just one function, this one. It's just one function, not 2 different pieces.
So by definition, the piecewise function must have at least 2 functions.
At least 2 functions, yes.
Okay.
Yeah. That's why here I used one color, because it's one function. But here I made sure, even in my silly example, that you see that these are completely completely different functions. Here I plug in numbers only in one function. Here I have to plug in numbers between this and this in one function, between these 2 x values in this function, and between these x values in this function. It's a very good question, actually. No one before asked that question. Thank you.
I just wanted to make sure I didn't associate a gap with strictly always meaning it was piecewise.
No, piecewise defined functions, sometimes they have gaps, sometimes they don't. They could be defined on all real numbers. I can give you an example. It's an excellent question. Let me give you an example, because this is a very good one. And I think we graphed it last time. Yes. Thank you. I should have said that last time. This is a piecewise defined function. The absolute value function. Okay, let's talk about that too. It's a very good point you're making. So, which page am I on? 5. Okay. So f of x equals the absolute value of x, just the base function. Because I need this. I need this, so I want to refresh your memory on that. Does anyone remember the formal definition of the absolute value?
The distance from 0.
That's correct. So this is the distance from x and 0, or between x and 0, I should say. Yeah. Or the distance from 0 to x. Okay, perfect. But the formal definition, how do we simplify that into a piecewise defined function? Because it is a piecewise defined function.
Just x and negative x.
Very good. X and negative x. If what? Trey, do you remember
if
that?
X, X, and if negative X, X.
If, so one more time. When we talk about piecewise defined functions, blah, 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 if, blah, 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 if, blah, 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 if.
Oh, it would be if x is greater than 0,
Excellent.
then if x is less than 0.
That's it. This is the formal definition of the absolute value. So that's why when we graph this function, and this is again to remember, carved in stone, extremely important. Negative infinity, 0, infinity. So can anyone give us the interval notation for these two? It's a good practice to do this again, anyway.
A bracket 0 infinity
Very good. And this one?
would be negative infinity 0, but they'd be in parentheses.
Correct. And you understand that this is everything. There is no gap here. But I will still write this to the right, touching this, the parenthesis to the left. Which function we use for the first piece?
Negative x.
Which function we use for the second piece? X. Good. So let's plug in some numbers. They're linear functions. So let's say -2 and -1. Let's say 1 and 2. So tell me what you get, Gia.
Wouldn't it be? It'll be 2.
Excellent. Very good. Derek?
1.
Perfect. Okay. So it happens that these numbers are the same. This is very important, right? No jump. Here, this function has a jump. On one side is 2, on the other is 1. So this is a jump. But here there is no jump. It's the same value. And of course 1 and 2. So when we graph the function, of course, -2, 2, and -1, 1, and 0, 0, and we know it's a v function. We graphed it, and this is the simplest one. So this is the absolute value of x. And this is called a corner. We're going to talk about that, what happens there later. So this is another example of a piecewise defined function, but with no jump. And the range, anyone? Nabitha?
Would it be all real numbers?
One more time, the range. For the range, we start low. We cross the graph with horizontal lines.
All numbers greater than 0?
Very good, awesome. Perfect. Okay, enough of that. So do we understand this? Very important to remember, we're going to use it. Very important. Do we understand the piecewise defined functions?
Yes.
Everyone?
Yes.
Okay.
Yes.
So find the equation of a line passing through the ordered pairs, and we have -3, 4, and we have 2, 5. What do we do? Anyone?
Find slope.
Find a slope, which is rise over run. I recommend label them. And the rise means the difference in y values. over the difference in x values. Please do not reverse the 2, ever. Okay, can anyone give us the numerator and the denominator here? Ian?
Would they both be 1?
So 5 minus 4 for everyone to see, and 2 minus negative 3 is 2. 2 minus negative 3. What do I have to write?
2 plus 3.
Very good. So the top is 1, the denominator is 5. So we determined the slope. Okay, next. What do I need to find after I find the slope?
Y-intercept.
That's a possibility. Since I have y minus y1 equals the slope times x minus x1, I'm not going to bother with the y-intercept. So this is 1/5, and it doesn't matter which one you want to use. Which point would you like to use? Negative 3, 4 or 2, 5? It doesn't matter.
2, 5.
Perfect. 2, 5 it is. 2, 5. Okay, and now I'm going to plug them in. Y minus 5 equals 1/5 x minus 2. Let's distribute. Can anyone distribute? Kush, can you distribute for us? So we have y minus 5 equals, and I want to distribute 1/5. What do I get?
X over 5.
So we have 1/5 x, or x over 5, that's correct, and then minus.
2/5.
Very good. Now remember, we have to move one term from one side to the other. The only thing it's going to happen is it changes its sign. So y equals 1/5 x minus 2/5 and plus 5. So let's do this on the side slowly so I don't have to do this again. But if I have to, I will. 5 over 1. The least common denominator. Oscar, the least common denominator? Perfect. 5 is the same here. Do I multiply the top of the fraction by anything?
Add the first one, it'll be -2.
Just 1, nothing. We don't have to do anything. 1 was multiplied by 5. What do I need to multiply the top by?
5.
Very good. So -2 times 1 is
2. -2.
good. Plus 5 times 5 is
25.
good. And the answer is
23 over 5.
so I hope that everyone understands this and we don't have to go back to it. Any questions?